Hello friends, welcome to another session on permutation combination. So we have done a couple of sessions already. I'll put a link in the description box. Please go through them. The first session was on fundamentals on permutation combination. I know some of you may have a little difficulty in solving permutation combination historically, or in the school days you were not very comfortable in that topic. But the way we have explained the foundational session absolutely from scratch and easily consumable by anyone at any stage of maturity in terms of permutation combination. So even if you are absolutely starting this for the first time, or you are confident around permutation combination, you both of you can go through the topics fundamental session, and that will help you to completely declutter your mind. If you have clutter in mind around permutation combination, it will help you declutter, or otherwise it will help you refresh the concepts. So this is one of the very important area for your CAT, NMAT, SNAP, IIFT kind of exam. So if we see, typically every year there are questions from permutation combination in all this exams. So basically a very important topic. That's why I'm doing 3 problem sessions on this. So the first session yesterday we covered, the last session, not yesterday, the last session we covered was around taking a sample problem and solve all the problems around all the type of problems that can come around digits in permutation combination, number of numbers, kind of problems. And that is one of the most favorite type of problem for CAT and MAT, and sometimes SNAP, IIFT as well. So today we are going to dive and talk about the topics in permutation, or problems in permutation combination, which does not directly require digits, but also some other type of problem. Typically the number of ways you can solve, the number of way you can distribute, so all that type of problem. So without further ado, let's get diving. So this is just a minute. So this is PNC problem session 2. Anywhere you find it any difficulty to understand, please drop a note in the comment section. I'll be responding to that, or else you can drop me an email given in the description box, and I will be able to help you from there. But please go through the first 2 sessions if you have not already gone through before you start this. So that way you can have a series of step-by-step understanding of PNC. By the next session, which will be a little advanced level problem, so you will be wrapping up permutation combination completely, and by this 4 session as a package, you should be able to gain understanding of all key concepts, all different type of problems of permutation combination. Okay, so let's get started. So let's see the first problem. It says there are 6 men and 5 women. So that means there are 6 men, 5 women. How many ways can you select 5 members so that there is at least 1 woman? So basically now I have total 11 members. Out of that 11 member, how many ways I can select 5 member where there are at least 1 woman? So one way to do this is a total ways of selecting 5 member minus total ways of selecting all 5 men. So basically what I'm trying to say is you have to find out, you have to make a group of 5 people. And in that 5 people, if you make the group all the 5 men, then only the case where you will not be able to include any woman. Otherwise, if the group of 5 does not have all 5 male, then by default you will be introducing 1 female to the group, and that's what it has been asked. So what is the way that there has to be at least 1 woman? So what it means by at least 1 woman is basically you can have at least, you can have 1, 2, 3, 4, or all 5 women, but you need at least 1 representation of woman in the group. So total way of selecting 5 members out of 11 members is 11C6, that we know. Choosing 6 people out of 11 people minus total way of selecting 5 men. So out of 6 men, if you are selecting 5 men, so that's what you should be focusing on. Okay. So why 65? Because out of 6 men, I have to choose 5 men. And out of 11 people, I have to choose 6 people. That is total way of selecting 5 members. And out of that, if I choose 5 male out of 6 male, how many ways I can choose 5 male out of 6 male? I can choose 65 ways. So that's the whole idea. Okay, I have to choose a member, 5 member. Okay, so this is 11C5, sorry. This is 11C5, choosing 5 people out of 11 people. So that is 11C5 minus how many ways you can take 5 men. So out of 6 men, how many ways you can take 5 men? So that is 65. So if you subtract this, all the other list of type of group that you are going to form with 5 members will have 1 female for sure. The other way of doing it is you can think of, there are at least 1 woman, they said, right? So you can think of, there is 1 woman, 4 men, 2 women, 3 men, 3 women, 2 men, 4 women, 1 man, or all 5 women, 1 man, 0 men. So this is also possible. So the first one is how many ways you can select 1 woman and 4 men. So out of 5 women, you can select 5C1 into 6C4. Then the next one is 5C2 into 6C3. Then the next one is 5C3 into 6C2. 5C4 into 6C1. And then 5C5. So if you add all of this, this will tell you the same value that you are getting here. So if you add all of this, but all of these 5 scenarios, you will get the same answer. So you can solve it either way, whichever way you are comfortable. Okay, let's go to the next problem. It says a particular woman is always present. A particular woman is always present. So in this case, what you need to do is you have to fix 1 position for a woman, and then the rest of the 4 positions can be filled in no matter what way possible. So I can pick all the 4 men, all the 4 women, doesn't matter. A particular woman has to be present. That means if that particular woman, I have set it out, so out of this 4 places, I have 10 choices, 10 members are available. So I don't know which woman, and then it cannot be any woman, it's a particular woman. So if I take her out completely, then the rest place can be filled in 10C4 ways. How? Why 10C4? Out of 10 leftover member, I have to fill up 4 positions, no matter there is no other restriction. So 10C4 is your answer. And the third one, a particular man is always absent. A particular man is always absent. So that means you have 5 positions left, but you have left with 10 member only. So to fill 5 position with 10 members, because you can't put 1 particular man. So 10C5 is your option. So out of 10 available choices, you have to pick up 5. There is no rest other condition. So this is the answer. So I hope you understand how from a set of members, how to form a group, what are the conditions, how to work around the constraints. So yeah, moving on. See the next problem. This says you have 10 questions. In how many ways you can answer at least 1 question? So for every question, say question 1, 2, 3, 4 till question 10, you have always typically 2 options. Either you answer or don't answer. These are the only 2 options you have for every questions. And whether you choose whichever options for whichever questions, there are another two options available for all the other set of questions. So for every answer, every option you choose, by option I mean either answer or you don't answer. So every option you choose for every questions, there are two options available for all the other questions. So that means 2 to the power 10 ways to answer. So then total there are 2 to the power 10 ways to answer, but this is not your answer. In how many ways can you answer at least one question? So how many ways you can answer at least one question? So that means you have 2 to the power ways to answer, but in that scenario, there is one scenario where you will choose don't answer for all of them. There is only one scenario possible, one scenario when you will not answer any question, and that is only one scenario. There is no more than one scenario that is possible where you don't answer any questions. So your final answer will be 2 to the power 10 minus 1. Okay, so that is the way you can solve. So there are 2 to the power 10 ways to answer this, and out of that only one way where you cannot answer any questions. So all the ones are if not answered. So that is only one way. The other way of solving this problem is out of 10 questions, they said you have to answer at least one question. So when you answer one question, you can choose 10C1. So out of 10 questions, you are answering only one question. So that you can do in 10C1 ways. If you think you will answer two questions, then 10C2, then 10C3 till 10C10. So this sum and this sum should give you the same answer, but you can solve it either way. So when I say you can answer at least one question, so first one tells when you answer only one question, second one tells when you answer two questions, three questions, and more. If you answer all the 10 questions, then it's 10C10. So there are multiple ways to solve a particular given problem. Whichever way you are comfortable, you can do it. So the idea is when they say at least one question, that means minimum one, and maximum there is no limit till all the questions are answered. So 10C1 to 10C10, you can add. 10C1 is when, I'm repeating, 10C1 is when you choose one question, you are answering one question, then you can answer any one of the 10 questions. So that's why 10C1. When you choose two questions to answer and not answer any other questions, so you can choose any two questions out of 10 questions. That's why 10C2. Similarly, when you choose three, all this satisfies the criteria of answering at least one question. So I hope that part is clear. You can solve the problem either way. Let's move to the next one. It says there are 13 friends. If they have to sit in a two different table, one is straight with 7 seats, the other is a circular with 6 seats. So 3, 4, 5, 6, 7, and then there is a circular one with 6 seats. 1, 2, 3, 4, 5, 6. So first, what we need to see here, 13 friends, two different table, one is straight with 7 seats and the other with circular with 6 seats. In how many ways? So basically, if I take 7 friends out of 13 friends and give them and make them sit in the straight table, then the rest 6 has to go to the circular table. So what I have to do is I have to just choose 7 friends out of 13 friends and make them sit in a straight table. The rest 6 has to go to the circular table. So for that, there is no choice I need to make, because the only choice I'll make is choosing 7 people out of 13 people. So the first part of your problem is choosing 7 people out of 13 people, which is by default ensuring the other 6 goes to the circular table. So if you have 7 people, so first you choose, and for each of these choices, you can arrange these 7 people in a straight table in factorial 7 ways. So that we know. So 7 people in 7 places can be arranged in factorial 7 ways. There is no other constraint. And for the 6 people, and for each of these arrangements, the 6 people that are going to the circular table, we know the circular arrangement has to be factorial 5, because if there are n people sitting on a circular table, the choice that you can make is n minus 1 factorial. So recall your foundational class, because in circular arrangement, you have to fix one particular position and rest of the positions can be arranged in reference to that particular fixed position. So you can only arrange n minus 1 people sitting in a circular table if of n people. Now, if the circular table was symmetrical from both the sides, which is not said, but if it was said, then it was n minus 1 factorial by 2, n minus 1 by 2 factorial. But that is not said here, that the circular table is symmetrical. Typically, in a set of a type of a ring, when both the sides are symmetrical, then it's n minus 1 by 2 factorial, because both sides are same. But if it is not similar and not said specifically, then we will not consider this 2 and we will focus on only n minus 1 factorial for this problem. So this is your answer. So first you have to choose 7 people out of 13 people and make them 7 for each of those choices. You have 7 people to sit in a circular straight table, so you can arrange them in a factorial 7 ways. And for each of that choices also, you have factorial 5 ways to arrange the 6 people that are going to the circular table. So I hope that is clear, and why multiplication is needed, that is also clear. So if any doubt, anything which you are unable to follow, please drop a note in the comment section. And also I would urge you to go through the foundational session. So that's where we said when there is an addition, when there is a multiplication, though I'm repeating that concept here, but it will be further more lucidly explained in the foundational session. So for each of the choice, for each of the arrangement, there are another arrangement. So that's why it's a multiplication here. Moving on. Said in how many ways you can divide 12 different boxes in the books in 3 boxes equally. Boxes are identical. So if the boxes are identical, so there are 3 boxes like this, and you have 12 different books, 3 boxes equally. So that means 4 books here, 4 books here, 4 books here, but these books are different. So the first box, so 1, box 2, box 3. So in the first box, you have 12C 4 ways, because you will choose 4 books out of 12 books to go into the first box. Okay. Now in the second box, you have left with 8 books, so 8C 4 ways. In the third box, you are left with 4 books, so 4C 4 ways. So your answer will be 12C4 for the first box. For each of these choices, you will have 8 books left and you have to choose 4. And again, for each of those choices for the second box, you have exact 4 books left, so 4C4. Okay, so this is your answer. So 12 different boxes, sorry, 12 different books, 3 identical boxes. So you have to put 4 in each, 4 different books. So how you choose the first 4 books to the first box, that will ensure for each of those choices, you will have 8 books left. And from that 8 book, you can choose any 4 books. And for again, for all those choices, you have 4 final books left for the last box. So there is typically no such arrangement possible. So 4C4 typically means 1 only, but this is the way. So first one out of 12, you are choosing 4. Next, for each of that choice, you have 8 choices left. I have to select 4. And for each of those choices, you have 4 lefts, out of which you anyway have to select 4. They said the boxes are identical. So if I have 12C4, 8C4, 4C4, but then since the boxes are identical, it does not matter which box I choose. So the 3 boxes can be arranged within themselves in factorial 3 ways. So I have to divide by factorial 3. Again, understand this. This is very important to understand. Why am I dividing with factorial 3? Since boxes are identical, so what we have to do is, it does not matter which box you choose as box 1, which box you choose as box 2, which box you choose as box 3. It's always going to be same, because for the first box, for the second box, for the third box. So internally, it does not matter which box you are choosing. So the arrangement of the boxes, the first, which is second, which is third, within arrangement of the boxes is insignificant here. So that's why we have to divide with factorial 3, because there are factorial 3 ways the box can be arranged among themselves. So if there are 3 entities, so it can be 1, 2, 3. There are 3 boxes, right? So you can put it as 1, 2, 3. You can put this as 2, 3, 1. You can put this as 3, 2, 1. Multiple ways, right? So there are 6 ways or factorial 3 ways you can label a box as 1, 2, or 3. Total 6 ways, because there are 3 boxes. So if there are 6 ways of doing that, right? So what are the 6 ways? The first one is 1, 2, 3, 1, 3, 2, then 2, 3, 1, 2, 1, 3, then 3, 1, 2, 3, 2, 1. Considering this first line, first row indicates the one box, second row indicates second box, third row indicates third box. So there are 6 ways you can label a box, but all that labeling will not be necessary because boxes are identical. So that's why you divide by factorial 3. If the boxes were unidentical, then you don't need to divide by factorial 3. It is straight away 8C4 into 4C4. Okay. So hope this is clear. Because then this multiplication with in between arrangement of boxes will also necessary. Okay. Now the next problem, they said, in how many ways can you divide 10 marbles among 3 boys such that each get at least 1 marble? So 10 marbles, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 marbles, right? And I have to put 3 boys. So 3 boys means if I put 2 bars, if I put 2 bars, then that will divide this into three segments. So if I put 1 bar here for one boy, another bar here for the second boy, so there are 3 segments that have been done. So let's say the first segment goes to one boy, second one goes to the another boy, third one goes to another boy. So basically, can we say there are 10 marble and 2 bars? So that basically represents 10 marble and 3 boys, right? So it is also the same way of writing A plus B plus C equal to 10, where each of them get at least 1 marble. So if each of them has to get 1 marble, then it is denoted as if A plus B plus C equal to N, and each of A, B, C are positive integer, then the number of solutions are equal to, and the number of solutions are equal to n minus 1 C r minus 1. Okay. So each of A, B, C are positive integer. Positive, why it positive? Because each of them has to get at least 1. So at least 1 means A, B, C has to be 1. So A means A number of marble to one person, B number of marble to another person, C number of marble to another person. If each of this has to be at least 1, then we are talking about positive solutions of A plus B plus C. Now, if each of A, B, C are positive integers, then the number of solutions that are possible is n minus 1 C r minus 1, where r is basically the number of elements here. So there are 3 elements here. So in this case, it will be 9 or I'll say 10 minus 1c, 3 minus 1, or 9c2. Okay. The other way of doing it is through this marble approach. So there are okay, let me just do this. So let's say there are these 10 marbles available, right? For 10 marbles, there are 9 gaps. Okay. So there are 9 gaps between two marbles. There is one gap. So there are 9 gaps. And let's say I have 2 bars available. To distribute it into 3 people, I have to place these 2 bars anywhere possible. So out of those 9 gaps, I have to place these 2 bars into 2 gaps. So I can place this here and here, like I have placed, or I can place this as here and here. So there are total 9 gaps available. So here you can say there are total 9 gaps available. And I have 2 bars to insert. If I insert 2 bar, that means the entire 10 marble will be divided into 3 segments. So I have 9 gaps available. I have two bars to insert. So I have to choose 2 gaps out of 9 gaps. So that means 9c2 ways. So this is also one way of thinking it. This is the formula which you can remember. So there are 2 gaps out of 9 gaps I have to choose. So that means 9c2 ways. If I had to choose, now let's think this problem when no one does not get anything. But that is the next problem we'll solve. But this problem, you can think there are 10 marbles. So there are 9 gaps. And you need 2 bars to insert in that 9 gaps. So you can choose any 2 gaps and insert that bar. So you need 2 gaps to be chosen out of those 9 gaps where you can insert those bars. And as soon as you insert those 2 bars, it will make the entire set of 10 marbles into 3 segments. And each of the segment can go to 1. Okay. Now, moving on, if you see the next problem, it typically says, in how many ways can you divide 10 marbles among 3 boys where a boy may not get a marble? So one person may not get a marble. So previously it was getting a marble. Here they may not get a marble. So what we say is a plus b plus c equal to 10, but non-negative solutions. What does it mean? Non-negative solution, non-negative integer solutions. Sorry. Non-negative integer solutions means a, b, c be greater than or equal to 0. In the previous problem, it was a, b, c greater than 0, right? Here, the challenge is we have to do a, b, c greater than equal to 0. So a, b, c can be equal to 0, right? So BC can be equal to 0 or ABC may or may not be equal to 0. Okay. So now if and first I'll tell you the formula for this. If it is a non-negative solutions, then the number of ways, the number of solution possible is n plus r minus 1 c r minus 1. So here 10 plus 3 minus 1 c 3 minus 1, or you can say 12c2 ways. 12c2 solutions possible, not ways, 12c2 solutions possible. So we know if it is a non-negative solution, that means some of these values can take 0. Obviously, integer solutions, some of these values can take 0. Then your answer is n plus r minus 1 c r minus 1. And if it is only positive integral solutions, then it is n minus 1 c r minus 1. You can remember from a formula standpoint. Coming back to the distribution ways, so there are again 10, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So then there are again, how many gaps are there? So there are 9 gaps between each of them. 1, 2, 3, 4, 5, 6, 7, 8, 9 gaps. Okay. total there are 9 gaps. Out of that, there is one gap, one place outside. Okay, and then there is one place outside here. So there are total 11 places. 11 places. But also, if you think, I can put, there are two more places here, because I can put 2 bars completely outside and give 1% the rest all. So what I mean by that is, let's say I will put 2 bars here. Okay, so A is equal to 0, B is equal to 0, B does not get anything, and then C will be completely equal to 10. So if I put 2 bars here, then that means first 2% gets 0 and the last 2% gets everything. So 9, so then I can have 2 positions to the left of it. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So then there are 9 gaps, 1, 2, 3, 4, 5, 6, 7, 8, 9 gaps. One position here that you can place 1 bar here. Okay. So that means the other side also you can place 1 bar, but you can also place 2 bars instead of one at the beginning and one at the end. So that means the first and second. So this 2%, A gets 0, B get 10, and C gets 0. Okay. There is also a possibility I can put all the 2 bars at the end. So that means A get 10, B gets 0, C gets 0. I can also put all the 2 bars at the beginning. In that case, A get 0, B gets 0, and C gets 10. Okay. And 1 at the beginning and 1 at the end. That typically means I will have to do your A is 0, C is 0, B is 10. So there are such 3 more extra places. So 9 plus 3, 12 more extra places to place the bars, and I have to choose 2 gaps to fill that. So basically, out of 12 choices, I have to make 2 choices where I want to place the 2 bars. Whether I want 9 gaps means 9 in between, then whether I put 2 at the beginning, 1 at the front, 1 at the end, or I have all the 2 at the end. So all the 2 at the end makes A as 10, B and C 0. 1 beginning and 1 end means A is 0, C is 0, only B is 10. 2 at the beginning means A is 0, B is 0, C is 10. So that way I have 12 choices to be made. So either way, you can remember this problem and start solving this. Okay, so these are the set of problems we thought of solving today, and hope these are helpful, and then we'll solve some of more this type of problem in the advanced session, and then solve few more level 2, level 3 kind of a problem. So this session is helpful, and if you have any doubt, please feel free to reach out and I'll be able to guide you from there. So you can drop a note in the comment section, or you can reach out to me by mail, whatever way it's feasible. See you next time. Thank you.